Hey guys, Mr. Mackey here. Now yesterday I was showing you more complicated simultaneous equations where we will end up with more than one solution for them. And I set you this challenge and you will need a calculator to do this. Now I have the equations 3x squared equals 4 minus y squared and 1 equals x minus y. And I wanted you to find for me what x and y are. Now, for the first one, I'm going to rewrite this equation so I have y on one side and x on the other. Now I'm going to do this by balancing, by adding y on both sides, because there's no point having a negative y where we could just turn it positive. So when I rewrite it by adding y on both sides, this equation will become y plus 1 equals x. Now, because I now know what x equals, I can substitute that into the equation above. So let me just rewrite it. I'm going to do an arrow, 3 brackets y plus 1 squared equals 4 minus y squared. Bit of a complicated one there, but let's do it. Now we expand this bracket. So y plus 1 squared, that's the same as y squared plus 2y plus 1. Now I'm not going to be multiplying everything here by 3 because that's what the 3 is meant to represent. It's a multiplier. So when you multiply, it becomes 3y squared plus 6y plus 3 equals the 4 minus y squared from that side of the equation. Now I can tidy it up a bit. So let's add y squared on both sides so I can get rid of that. That becomes 4y squared. The 6y stays like that, and then we subtract 4 on both sides, so minus 1, minus 4 here, minus 4 here. So it becomes 4y squared plus 6 minus 1 equals 0. Now I don't know about you, but I don't think we can factorise this. You can try, but I can't think of any ways we can do it. So we're going to be using a method which doesn't use factorising. And I have taught you this method. We're going to be using the quadratic formula. So that's A, that's B, that's C. So let's enter our B, which is negative, which is 6. So we do negative B, so we do negative 6, plus, and our O, and then we do the root, B squared, so 6 squared, minus 4 times minus 1, because that's what C is, times 4, because that's what A is. All over 2 times our A, which is 4. It's a bit of a complicated one to follow. If you aren't sure on what the quadratic formula is and how it works, imagine that's A, that's B, and that's C, and this is the quadratic formula. So substitute them in there. And from this, you will get two y values. The first y value you get is negative 3 plus root 13 all over 4, and the other one is negative 3 minus root 13 all over 4. So what do you think we have to do next to find our x? That's right, we substitute our y values in there. Now from that we're going to be adding our 1s to both of these values to get to x. So the values of x, the first one with this substituted in would become 1 plus root 13 over 4, and then our other x value, which is when we substitute this in, would become 1 minus root 13 over 4. This is probably one of the hardest challenges I've ever set you, but as long as you remember to use the quadratic formula and you remember to substitute afterwards, it's absolutely fine. Now we're going to be moving away from using these kind of simultaneous equations today. We're going to be on something completely different, and we're going to be focusing on this symbol, or this symbol. What do they mean? Let's find out. Now we're going to be focusing on inequalities today. And for inequalities, all you need to do is understand what these 4 different symbols mean. Now for the first symbol, this means that it is greater, that one value is greater than the other value. This one means that one value is less than the other value. This means that the value is equal to the other value. Now this is the same as that one with a line. This means it's less than or equal to the other value. And this one means it's greater than or equal. Now, one of the biggest things I used to really struggle to grasp when I was younger was how to tell apart this side and this side. How do I know this one means greater than? How do I know this one means less than? How can I tell them apart? And before we do inequalities, I want to show you how I did this. And to do this, I'm going to choose two different values. I'm going to choose a 4 and a 5. Now, which of these values is smaller? It's 4. And because that 4 is smaller, it wants to look tough in front of the big number. So it creates its own giant mouth to try and eat the big number. Because when you eat big things, you get bigger. And that's the same as the less than. It's telling us that the number that has the giant mouth to eat the bigger number is less than. So how then can we tell that apart with the greater than? Well, let's do it with a 6 and a 2. This time the 2's the smaller number, so it gets its own mouth to eat the 6. And that's how we know, because it's pointing, the mouth is attached to the smaller, or the number that's less than the greater. And that's how you tell them apart. So, whenever you have two values and you want to see if it's greater than or less than, you find the smaller number and you attach a mouth to it, and it's eating the bigger number. That's how we tell. But that's enough about how we can prove it. Let's now use inequalities to solve equations. Now, I have this equation. 3x is greater than 9. So how can I find out what x is? Well, the problem with inequalities is you will never get an exact value for what x is. You'll always get a range of values for what x is. So let's still balance it as if it's a typical equation. We divide by 3 on both sides, so it becomes x is greater than 3. That doesn't tell us that x is 3. It means that whatever our value is on a number line, so this is 0, this is 1, this is 2, this is 3, our x value will be greater than 3. It could be any number that's bigger than 3 on this number line. So it could be 45. Substitute it in. 45 is bigger than 3, so it works. That's what inequalities are meant. It's meant to give us a range of different values that could work for x. What about this one here? 2x plus 5 is less than 17. Let's balance it. So let's subtract 5 on both sides. This becomes 2x is less than 12. Then we divide by 6 on both sides, so it becomes x is less than 6. Which basically means that if we had a range of values, x could be anything as long as it is less than 6. So let's try this one. Let's do a bit of balancing. So if 3x plus 4 is less than x minus 6, let's balance firstly by moving all the x's onto one side. So let's subtract an x on both sides, so it becomes 2x plus 4 is less than negative 6. Then we have to subtract 4 on both sides, so we can balance out, so x on one and values on the other. So that becomes 2x is less than negative 10. And then once we've done the final bit balancing, divided by 2 on both sides, we have x is less than negative 5. So I have x minus 3 is less than or equal to 3x plus 13. Now this one's going to be a bit more complicated as, well, we have got bigger values on that side. All the others, we've been able to balance it, so we still end up with a positive value for x on this. But if we do that, we'll end up with a negative. So I'll show you what I mean. For this, the most likely thing is we then subtract 3 on both sides. So that becomes negative 2x minus 3 is less than or equal to 13. That looks a bit messy, doesn't it? So here's what we're going to do. We are going to swap everything over. Change those into positives, change that into a negative. But when we do that, we also have to swap the symbol. And because we're swapping the symbol, we're changing it from less than or equal to greater than or equal to. So I've changed it to 2x plus 3 equals negative 13. It's the exact same, I'm just swapping it round. So 2x plus 3 is greater than or equal to negative 13. We then subtract 3 on both sides. So 2x is greater than or equal to negative 16. And then we divide by 2 on both sides. So our x value is negative 8. Our x is greater than or equal to negative 8. So here is your challenge for today. I have x squared plus 3x plus 2 is less than 0. I want you to find the range of values that x could be when solving this problem. Could be tricky, but I'm sure you can do it. Good luck, guys. Take care. Have a good evening. And we're going to be doing even more algebra tomorrow, so good luck.